In this video, we will look at the difference property of logarithms. So suppose f of x is equal to b to the x, and f inverse of y is equal to log base b of y, based on the fact that the logarithm function undoes this basic exponential function. So let's start by evaluating f of u minus v. So f of u minus v is a base of b raised to a power of that input, so u minus v. Recall that from exponent properties, b to the u minus v is equal to b to the u divided by b to the v. But b to the u is just equal to f of u, and b to the v is just equal to f of v. So f of u minus v, if we subtract in our inputs, we end up dividing our outputs. Since the output of f is the input to f inverse, and vice versa, having the fact that subtracting in the input of f results in dividing the outputs of f means that dividing in the input of f inverse should result in subtracting in the output of f inverse. So f inverse of m divided by n should be equal to f inverse of m minus f inverse of n. Now this f inverse takes y as an input and then outputs log base b of y. So we can rewrite both of these to say that log base b of m divided by n is equal to log base b of m minus log base b of n. Again, this kind of looks scary. It's intimidating. We have a lot of symbols here, but just remember that anytime we subtract in an exponent, we end up dividing the corresponding powers. And so dividing in the input of the log function should result in subtracting the outputs. So we can go ahead and generalize this and say that for m, n, and b greater than 0, where b is not equal to 1, we have log base b of m minus log base b of n is equal to log base b of m divided by n. And again, recall that we can go both ways with this equation. If we have something written in the form of the left-hand side, we could then rewrite it in the form of the right-hand side. Or vice versa. If we had something written in this form, like on the right-hand side, we could rewrite it to look like the left-hand side. So let's look at a couple numerical examples of this. Consider the expression log base 3 of 10 minus log base 3 of 14. We could rewrite that as log base 3, and since we're subtracting the outputs of logs, we're going to divide the inputs. So we'll do 10 divided by 14. So log base 3 of 10 minus log base 3 of 14 is equal to log base 3 of 10 divided by 14. On the other hand, we could take an expression like log base 7 of 5 and write that as log base 7 of some input minus log base 7 of some other input, so long as these two inputs divide to give us a value of 5. So for example, we could input 60 here and then 12 here, and that would be true because 60 divided by 12 gives us 5.